Okay, so today we are going to solve logarithmic and exponential equations for x. We've graphed them, we've looked at how to express a log as an exponent, now we're going to solve. So there's a couple things we need to use. The change of base formula, something we'll be using. And remember what that is. If I have the log base b of a, that is equal to the log of a, the bigger number, divided by the log of b, the little number, the base. Now remember, we can also use calculator, and remember we use math log base, which is the A button. Okay, so we're going to use that. Logarithmic and exponential inverses. What is that? That is this. If I have the log base b of b to the x equals x, these two things are equal. So what's really happening here? Well, we know that when you have the base and the argument of the base are the same, what does this all cancel out to be? 1. So x would equal x. Or we could look at it like this. This is also called the inverse. If I have the log base b of a to the x, this is equal to, remember this is a condensed version, and I can expand it by taking the x, moving it over here to get x times the log base b of a. Now remember that we can solve this portion of our function with a calculator, okay? Or we can just solve it by saying b to what number is a? Okay, that's what this is. All right, so we're going to be using those in the next 4 methods. We're going to use 4 methods, and they're more like 4 different situations. We can use like bases, everybody underline like bases, to solve exponential equations by expressing each side as a power of the same base. So if b to the m is equal to b to the n, if the bases are the same, then m equals n. Here's our steps. Rewrite both sides of the equation with the same base. And if that doesn't make sense, it will. Number 2, set exponents, m and n, equal to each other. And lastly, solve for x. Okay, so if we can, we're going to let the bases be equal, set m equal to n, and solve. Here we go. I have 3 of x. I can write 9 as like this, 3 squared. So I'm rewriting the number 9 as 3 squared. I have the bases are equal, therefore x equals 2. Okay? So I'm going to rewrite this function as a power, both of them as power of 3. So I have 3 to the 2x plus 1 equals, what is 81? Well, it's 3 to the 4th. Now the bases are equal, so 2x plus 1 is equal to 4. 2x equals, subtract 1, then x is equal to 3 halves. Okay, so I divide both sides by 2. Let's do it again. Rewrite both as a power of 5. Now I have 5 and I have 2, and there's an x already up there, so I just multiply them together. Is equal to 5 to the 3rd. Therefore, 2x equals 3, x equals 3 halves. And that's that answer. All right, now let's write this in a couple steps. We have x, 8 to the x, and a 2 here. I know I can write 8 as 2 cubed, then times x, because I've got the x already up there, is equal to, how can I express this? This is 1 over 2 to the 1/2. But I want it to the base 2. So I'm going to take it, say 2 to the 3x is equal to, how do I get that to the numerator? 2 to the negative 1/2. Now my bases are exactly equal. 3x equals negative 1/2. X is equal to, I'm going to take negative 1/2 and divide it by 3. Okay, so remembering how we do the division of fractions, we multiply the numerator by the reciprocal of the denominator to get x equals negative 1/6. Okay, all right, there we go. So that's how we use method 1. Let's go on to method 2. All right, method 2 says take the log of both sides of the equation and use the properties of logarithms. So we're going to take the log of both sides. Use the properties of logs to obtain a decimal approximation. Here we go. Here's what we're really going to do. We're going to isolate the exponent, which is b to the x. We're going to get that all by itself, get rid of everything else. We're going to choose a base, b, and take the log of both sides. This will make sense in a moment. And then we're going to simplify and solve for x. All right. This makes a lot more sense when you do it. So this one, we don't need to isolate b to the x. It's already all by itself. So we want to take the log of both sides. If I take the log base 10 of 10 to the x, if I take the log of this side, then I want to also take it's just like algebra, take the log of the other side. What happens when I have log base 10 of 10? Let's do that on our calculator. Okay, I want you guys to put in the hit your math function, go up to log base, and I want you to hit the log base 10 of 10 and then to the second power. What happens when I have the same base and the same argument? What happens? Let's see it. Well, what happens is that log 10 and 10 cross out to be 1. So I get 1 squared, which is 1. 1 times itself is 1. So let's take it through another base, because 10, that's kind of, maybe you're not seeing it as clearly. Let's take log base 3 of 3 to the second power. These are going to cancel out to be 1, and your answer is going to be 1 to the second power. Yeah, I guess that's how it's going to be. Okay, so here we go. We're going to, so these cancel, I get x equals, now this I can do on my calculator, so let's just do it. Math, log base, and I'm going to put this in, base 10 to the 9.43, and I hit enter, and my answer is 0.97, and I'm going to raise that, I'm going to round it up, 0.975. 0.975. Okay, so let's do it again. In the second one, what is E? E is the log. I want to take it to the log base E of E, right? I want to take the log of both sides, and I need to take it to the log of base E, which equals, if I'm going to do it this side, I have to do it this side, the log base E of 0.97. Well, what is the log base E? It is the natural log. So I could just take the natural log of E to the x is equal to the natural log of 97. I'm just rewriting log base E. I just want you to see why it cancels out to 1. Okay, when I take the natural log of E, it cancels out to 1, and I want you to see why. So this just cancels, and I get x is equal, and I can do the natural log of 97 on my calculator. So hit the natural log button, 97, enter. and I get 4.574. Okay. I'm sorry, that was 0.97, so let me do that again. I apologize. The natural log of 0.97 is equal to negative 0.03. Negative 0.03. Sorry, I lost that decimal place. Okay. Now here we have to remember about step 1. Isolate the exponent. We want to isolate e to the 2x minus 1. So let's subtract 3. I have 6e to the 2x minus 1. I'm going to subtract 3 from both sides to get 36. Well, I still have the 6 here that I need to get rid of, so I'm going to divide it out and get e to the 2x minus 1 is equal, divide both sides by 6, and I get 6. Now, I have an e here, so I'm going to take the natural log of the left side and therefore the natural log of the right side. So what happens here? Well, the natural log and e cancel out to give me 2x minus 1 is equal to, I do that on my calculator, the natural log of 6, so do that with me, is 1.792. 1.792. I'm going to add 1 to both sides to get 2x equals 2.792, and x is equal to, divide by 2, and you get 1.396. Okay, so that is the answer solving for x. Let's do one more. 2 different bases. How is this going to work? Well, I want to get to the x. So what I'm going to do is I'm going to choose the log base 4. I'm going to take the log base 4 of 4 to the 3x minus 1. Now I have to take the log base 4 of the other side, just like algebra. Okay, what am I going to do now? Well, now these are going to cancel out to 1, bringing this down, 3x minus 1, and then I'm going to use the expansion of logs to bring this x over here and say equals x times this, the log of base 4 of 9. Now I can solve the log base 4 of 9 on my calculator, so let's do that. Math, go up, okay, the log, what did I do there? I don't know what I did there. Math, the log base 4 of 9 is equal to 1.585. So this is going to be x times 1.585 is equal to 3x minus 1. So now this is really 1.585x, right? Equal to 3x minus 1. So what am I going to do here? I'm going to subtract this from both sides. So 3 minus 1.585. Oh, why does it have a double answer? 3 minus 1.585, and that's really 3x minus that, is going to be 1.415x. I subtracted that from both sides, and I have a negative 1 here. I'm going to add it to both sides, equals 1. So now I'm going to solve for x. I'm going to divide both sides by 1.415. So 1 divided by 1.415 is equal to 0.707. Now when so x equals 0.707. There we go. So that's my answer. Now let's, is that right? Yep, okay. So what I want you to do is to try these. Okay, so turn off the tape and try 1, 2, and 3, and the answers will be put up for you. Okay, I'm going to move on. All right. The third method or situation is when we need to exponentiate. We just took the log of both sides. Now we're going to raise things to the same base. We're going to raise both sides to the same base, because what happens if I have b to the log base b of x? Well, these cancel out to 1 times x equals x. just like the last problem, but in reverse. So here's what we do. Isolate the log. And what you usually are doing here is condense to one log. You're going to condense it. Then you're going to what's called exponentiate. And that'll become clear in a minute. And then we're going to solve for x. Now, when we get to method 4, we're going to need to check for extraneous roots. That means you get an answer, x equals something, but it turns out that that value does not provide a real solution. And here's what I mean. You can't take the log of a negative number. Negative number. All right? So when you get an x, an x is negative number, it's not going to be real. All right, we'll show you that when we get there. Okay, we have this function. This is for exponentiating. This is when you have the log base of the same and this set equal to each other. How do I solve that? Well, I exponentiate. I take both sides, and because this is a 3, I raise this 3 to the log base 3 of 5x minus 1. I do the same thing to the other side, is equal to 3 to the log base 3 of x plus 7. Well, these just cancel out to 1. So this moves down. 5x minus 1 is equal to x plus 7. So if I have the same something with the raised to the log of the same base, they just cancel to 1. And you can try to see that on your calculator, okay? Now, what I'm going to just keep going here. So just take my word for that. I'm going to subtract x from both sides to get 4x equals 8 and solve x equals 2. Right? I only have one root. It is the answer. It's not negative. I'm good. All right. You guys try these two. I'm going to move on to method 4, when you have to use condensing as well. Now here, I might have to check for extraneous solutions. When to use. Okay? We use the extraneous solutions, checking for those, when a solution will result in the log of a negative number. That's when we check for extraneous solutions. Here we go. I'm going to condense first. So on the left side, I can condense the log base 2 of, now this is going to be x times x minus 7. Okay? And all I'm doing is condensing. I'm not taking the log of both sides at this point. So now I'm just going to multiply these together. So I get the log base 2 of, distribute this, x squared minus 7x is equal to 3. Now I have a log on one side. What can I do to get rid of a log base 2? Well, I can exponentiate. So I do 2 to the log base 2 of x squared minus 7x is equal to, if I do this on this side, I have to do it on the right side. Well, that's just a number, so that'll work. Now these two are going to cancel. I'm going to get x squared minus 7x is equal to 2 cubed is 8. Now, I see that I have a quadratic almost. I'm just going to move this over to get x squared minus 7x minus 8 equals 0. And I know that I can factor. Okay, so I get x, what multiplies to negative 8, but adds to negative 7. Well, if I make this negative and this positive, that'll work. So now I get two solutions. I've factored, and I say, well, okay, x equals negative 1, and x equals 8. Now I'm going to check for extraneous solutions. So let's check the x equals negative 1. Let's check it. So I'm going to back to my original function. And so I'm going to say the log base 2 of negative 1 plus the log base 2 of -1 minus 7, which is -8. Is that equal to 3? Well, I want you to take your calculator with me. Hit the math button. Oh, turn it on. Math button. Go up to log base, and I want you to put in -1, the log base, base 2. Delete. The log base 2 of -1. Error, non-real answer. So I can't take the log of a negative number. So this is not real. So let's check x equals my other solution. X equals 8. All right, the log base 2 of 8 plus the log base 2 of 8 minus 7. Is that equal to 3? Well, what is the log base 2 of 8? 2 to what power is 8? 3. Now this 8 minus 7 is 1, right? That's 1. So 2 to what power is 1? So that's going to be 0, right? 3 plus 2. The way you get to 1 is you take any number to the 0 power. So that's going to be 0. Does 3 plus 0 equal 3? Yes, 3 equals 3. And that's a check. Okay, let's move on. And we'll do one more, and then you guys will do the next 2. I want to pick, let's take the middle one. I think that's the most challenging, so let's check it. And let's do this. So first I'm going to condense, okay? Condense it. I take the log base 2 of 3x times x plus 2. That is equal to 1. So I have to do that multiplication first. The log base 2 of distribute 3x squared plus 6x is equal to 1. Got to get rid of that log base 2, so I'm going to exponentiate 2 to the log base 2 of 3x squared plus 6x is equal to 2 to the first power. These cancel. So I get 3x squared plus 6x equals 2 to the 1 is 2. Move the 2 over. 3x squared plus 6x minus 2 equals 0. Now I'm going to have to factor. See if I can factor. So when I do factoring, when I have an a greater than 1, what do? Let's go over here. And I say -6. What multiplies to a times c, -6, but adds to 6? Well, do 1 and 6, I need to add to a positive, so the smaller number will be negative. That doesn't add to that. What about 2 and 3? That multiplies to -6, but doesn't add to 6. Oops. This is not factorable. So, what do I do when something is not factorable? Well, I use the quadratic formula. So, x is equal to negative b plus or minus, negative b is -6, negative b plus or minus the square root of b squared. What is b squared? 36 minus 4 times 3 times -2. All over 2 times a, 2 times 3. So, the quadratic formula, and I'll just write it up here, negative b plus or minus the square root of b squared minus 4ac. All over 2a. That's your quadratic formula. All right, so x is equal to -6 plus or minus the square root. Now, you have two negatives here, so I'm going to have a negative times a negative is going to be positive. So this is going to be added to 36. So I've got -12 times -2 is positive 24. 36 plus 24 is 60. Okay, so I have 36 plus 24, that's the square root of 60, all over 6. I wrote that out. I'm going to write it again. So I'm going to separate these out now, and I'm going to get negative 6 over 6 is negative 1 plus or minus the square root of 60 over 6. Is there any perfect squares in there that I can take out? Well, 4 goes into 60, so that is equal to, let's, again, more scratch work up here. If I have the square root of 60, that is the square root of 15 times the square root of 4, which is 2 radical 15. So, writing this one more time, x is equal to negative 1 plus or minus, and I'm going to get 2 radical 15 over 6, which is going to be, these are going to cancel, 2 and 6 to be that. So this is my answer. Okay? Now, when I work this out on the calculator, I'm going to say, so this is equal to, let me write it again, negative 1 plus or minus the square root of 15 over 3. That's going to give me 2 answers, right? So I say negative 1 plus the square root of 15, I'm going to say that, enter, and I'm going to divide that, wait a minute, what did I do? I need to make sure that this is in parentheses. So negative 1 plus parenthesis the square root of 15 divided by 3. Okay? So I need to make sure that I'm putting this into the calculator exactly what I want. Now that is 0.29, positive 0.29. Now let's do the other half. Negative 1 minus parentheses square root 15 divided by 3 parentheses, what is that? That is negative 2.29. Negative 2.29. Now when I check this, okay, I'm going up to check. I'm going to check x equals 0.29. What's going to happen? The log base 2 of 3 times 0.29 plus the log base 2 of 0.29 plus 2 of 2.29 is equal to 1. All right, so I'm going to do this on my calculator, and so I get the log base 2 of 0.87 plus the log base 2 of 2.29. Does that equal 1? Well, this turns out to be negative 0.2. This turns out to be plus 1.2. Does it equal 1? Yes. I get 1 equals 1, and that's a check. Now I'm going to check the other factor. X equals negative 2.29. So back to the beginning. The log base 2 of 3 times negative 2.29 plus the log base 2 of, what's negative 2.29 plus 2? That's negative 0.29. I just did that in my head. Does it equal 1? Well, here we see the problem. This is going to give us a negative. This is going to be the log of a negative 6 point something. Okay, this turns out to be the log base 2 of negative 6.87 plus the log base 2 of negative 0.29. This is a non-real answer because I cannot take the log of a negative number. Okay, so you got to check your answer. So the only solution that works is 0.29. That is the answer to this problem. All right. I'll see you next week.